Okay, so I hope you guys can hear me now. Sorry earlier. Medyo nawala yung ating Wi-Fi connection. It usually is having trouble at this time of the day. So I'm glad we were able to restore it. So yeah, welcome to our lecture series. This is educational statistics for beginners. So for today, we're going to we're going to discuss about hypothesis testing, and we'll be performing some tests using our SPSS software. Okay, so I'd like to say hello to everyone. I think we have 12 students online at the moment. I guess we have supposedly 20 plus, but I don't know what happened to the rest. Okay, so let's begin with our discussion of hypothesis testing. Now, just to give you an idea, um, hypothesis testing is an essential procedure in statistics. Okay, so we know that a hypothesis test evaluates, for example, two mutually exclusive statements about a population to determine which statement is best supported by our sample data. So um, when we say that a finding, for example, is statistically different or significant, that's because we use hypothesis testing. Okay, so this is essential, especially for those who will be conducting a research, because you must have an understanding of hypothesis testing and statistics as a whole, so that you could jumpstart with your research. In your case, with your thesis. Okay? So dapat meron kayong deep understanding of statistics, most especially your hypothesis testing. Okay? So when we talk about hypothesis testing, okay. Well, technically, when we talk about hypothesis testing, it's the use of statistics to determine the probability that a given hypothesis is true. Okay? Now, take note that kung ititest natin ito, it's either we reject our hypothesis. Okay? Now, we have two kinds of hypothesis. Okay? First is your null hypothesis. So the observations have no significant difference or relationship, or that the observations are the result of pure chance. Okay, they say that null hypothesis is our working hypothesis. It's the hypothesis that we are going to reject, or the hypothesis that we fail to reject. Okay? So, palagi kong sinasabi, since I am serving as a statistician to most students, especially in the graduate school, to students who are okay, so I think we are having a hard time with our internet connection. Okay, so na-restore na yata. Alright, guys, if nawala ako, you can just send a message. Okay, para alam ko if I'm still on or not, because like what I said, I'm having a hard time with my connection at the moment. I don't know what's wrong with 3 o'clock in the afternoon, but usually something is, or the connection is not good at this time of the day, but it's the only time that I am available. So I am conducting our class now. Okay. All right. So going back, I think you lost me. We have null hypothesis, or usually this one is denoted as H sub O or HO. The observations have no significant difference or relationship, or that the observations are the result of pure chance. Just like what I said, this is the hypothesis that you're going to reject, or that you will fail to reject. Okay, so for example, if you would like to find out if, let's say, brand A and brand B, okay, you would like to see if there's a statistical difference on their effectiveness, for example, of course, the null hypothesis will be that there is no difference in their effectiveness, or in other words, the two are equal in terms of their effectiveness. Okay, that's our null hypothesis. Now we are going to make use of a statistical test, therefore, for us to have a basis on rejecting our null hypothesis. Okay, so for example, we're going to make use of a test or a statistical test to really prove that either there is a difference or there is no difference in their effectiveness between brand A and brand B. Okay, so in your case, when you will be conducting your thesis, okay, most of the time, I see problems in thesis, like, is there a difference in the responses of the respondents in terms of, or when group according to their sex, either male or female. So if you would like to find out how the students, of if there's a difference on how the students actually answered the questionnaire, okay, among males and females, then you're going to conduct a test, okay? And then we have your alternative hypothesis, or H sub A, okay, or HA, that the observations show a real effect combined with a component or of chance variation. So in other words, there is a significant difference or relationship. Okay, so um, your HA, if you rejected the null hypothesis, okay, then it means that what stands would be your alternative hypothesis, or your H sub A. So for then, if null hypothesis shows that the means of, let's say, two groups are not actually equal, or if there is a difference and you fail to reject that, and you reject that, I mean, then your conclusion would be your alternative hypothesis, that there is an effect, or there's a difference, or there's a variation between the two groups. But in your thesis, okay, or in most research, what is stated only is the null hypothesis. That's why, I like what I mentioned earlier, it's the null hypothesis that is you're going to reject, or you will fail to reject. Okay, so ito yon. Previously, some teachers would tell you na accept or reject the null hypothesis. There's no such thing as accept the null hypothesis. Usually we say we fail to reject the null hypothesis. Okay, so I see a lot of tables in graduate school theses wherein they would write the decision as accept HO, where in fact you do not accept HO, because HO is just rejected, or you fail to reject the HO. So you do not write there accept HO. Okay. So what I usually do when students would tell me to serve as their statistician, I would write in the summary of tables, for example, if I fail to reject the null hypothesis, I would write there failed to reject null hypothesis, or failed to reject HO. Okay, so it says there here on our slide, note that the null hypothesis is the hypothesis that is being tested. So it's the null hypothesis that you will see in most of researches. Now, your hypothesis, by the way, guys, should be when you will be writing your research based from your statement of the problems or the problems which you have written in your research. So, nakabase dyan yung ating hypothesis or the null hypothesis that you're going to write in your research. So, dyan nyo siya ibabase. Okay, so it's a one-to-one relationship. So, for example, sa problem ninyo is to determine the difference between uh, the preferences of male and female. Then you must have one null hypothesis for that. Okay, that there is no difference in the preferences, significant difference in the preferences between male and female, for example. So, 1:1 yung relationship natin. Okay. When, of course, you're going to make use of hypothesis testing in the problem. Okay, so like a test of difference or a test of effect, relationship, okay, yung mga yon, they call for the use of the null hypothesis. Okay, and we're going to make use of a statistical test to be able to prove that. All right, so let's move on. Now, before we perform tests using your SPSS, let's try to understand first the difference between parametric and non-parametric tests. Okay, so here are the differences summarized in this matrix. Okay, for the distribution of population, for parametric, it assumes that a population has a particular distribution. Example, a normal distribution. But in reality, when you will be gathering your data for your thesis, you cannot really see a perfectly normal distribution of the population. Okay? Basta pag nakita nyo, lalong-lalo na pag kokonti yung samples ninyo na kinuha or yung respondents ninyo, it will not be visibly normal. But as long as, let's say, pag grinaph ninyo, it somewhat resembles a bell-shaped curve pag grinaph natin. You know what a bell-shaped curve is? So medyo malapit siya sa bell-shaped curve, then we can say that the distribution is normal. So in other words, if the distribution of the population or is a normal distribution, then we can make use of your parametric test. However, if the distribution is not normal or somewhat skewed, it does not really follow the bell-shaped type of graph, then we can opt to use a non-parametric test because this test do not care about distribution. In other words, it's distribution free. So wala siyang pake kung skewed ba yung distribution mo, hindi bell-shape yung curve. Okay, so pwedeng gumamit tayo na non-parametric test. Now, in terms of the variances of population, okay, this was in your module, yung variance, okay, standard deviation, then you have variance. So when we talk about variances, it's the square of the standard deviation, okay? Now, for the variances of populations, parametric test, it should be homogeneous, okay? In other words, they should have equal variances assumed. Okay, I'm sorry about the noise. Okay, let's continue. So in terms of the non-parametric test, equal variances is not an issue. So any will do. Now, your question would be, how do we know that the variances are equal? Okay, there's a test for that we can perform to find out if the variances of population are equal. Okay, so we'll get to that later. Now, for the outliers, okay, um, parametric tests are sensitive to outliers, while non-parametric tests is not sensitive to outliers. In other words, if in your data there are outliers, then you may opt to use non-parametric tests. Okay, but what are outliers? Okay, outliers are these are scores or I think data set, okay, which are either extremely high or extremely low. Okay, so we call them outliers. Well, a rough example to understand about outliers is, let's say we have 10 data sets. For example, we have um, one, maybe let's say, one, two, two, three, three, and then you have two, you have four, you have five, five, another five, and then there's a score. The 10th score is like, let's say, around 28. So if you notice, 28 is far from the clustering of the first few data sets. So we say that that data or that number is an outlier. Okay, it's either extremely high or extremely low. If there are outliers in your data set, then opt for non-parametric tests. But if there are none, then you opt for parametric tests. Okay, this may sound, let's say, new to you, but as we go on later, you'll see and you'll begin to understand what parametric and non-parametric tests are. Now, for sample size, okay, for parametric tests, it requires large sample size. Okay, large sample size. For non-parametric tests, um, if the sample size is small, then you opt for non-parametric tests. Okay, why? Because when your sample size is small, there is a high chance that the distribution of the population is not normally distributed. Okay, kasi kokonti sila. So, hindi, malaki ang chance na hindi siya normally distributed. Okay? Pag malaki yung sample size mo, ibig sabihin, malaki yung population mo. So, it means na there is a high chance that the distribution is normal. Okay? Kaya minsan, pag tinatanong ako ng mga researchers, ilan po ba ang sample size na kukunin ko? So, I would always answer them kasi yung mga iba dati, they make use of a formula, like a Slovin's formula, to determine the sample size of a population, okay? Which is not accurate, itong Slovin's formula. Okay, that's the old way of finding how many samples should be taken from a population, okay? Because if you try to keep, if you are going to compute, for example, for a sample size using the Slovin's formula, you will discover that there's a limit on the number of sample size being given by the formula. So as you increase the number of population, lumalabas na meron siyang limit. Okay, I'm not sure if what's the limit. I think that's around 300 or 400 something. Pero may limit siya. So for example, if you have 20,000 population, 30,000, and 1 million population, lumalabas na may limit lang yung inilalabas ng formula. So hindi siya therefore advisable na gamitin. Kasi I think, if I'm not mistaken, that's around 4, okay, or more or less 400 samples lang ang nilalabas ng Sloven's formula. Kaya when they ask me, ilan ba ang tapat na kukunin ko na population, I would always tell them na the more sample, not sample, I mean. So I would always tell them that the more samples you get from the population, the more reliable the results. Okay? And then we also have statistical power. Okay? Assuming that no violation on the parametric assumption is. Okay? So let's say all the assumptions for parametric test are met, then the statistical power of parametric test is higher, or it's powerful. For non-parametric tests, it's less powerful. Okay, what does it mean? Okay, a statistical power is the ability of a test to detect an effect. That is, the effect actually exists. Less powerful means less likely to detect a true effect. Like differences, correlations, if the assumptions for parametric tests are met. So in other words, pag na-meet yung mga assumptions ng parametric tests, if all the assumptions, these are the assumptions for parametric tests. No, I mean, these are not the assumption. The assumptions will be given to you test by test later on, okay? So let's say na-meet mo lahat yung mga assumptions for parametric tests, but you still opted to use non-parametric tests. That's where your statistical power becomes less powerful, okay? So your question would be, then why should I use a non-parametric test? You will use non-parametric tests if the assumptions for parametric tests are not met. Kung hindi na met, then go for non-parametric tests. Okay? Well, some of the assumptions are ito. Sinasabi ko nga, yung normal distribution and many others. Okay? I will let you know later on yung mga different assumptions for parametric and non-parametric tests as we start discussing the different statistical, simple, okay, and basic statistical tests. Okay, and this is the first one. Okay, I hope you guys can still follow. If you have questions, you can just send a chat, okay, in our live stream para masagot ko. Pag nakita ko ay sasagutin ko yung mga questions ninyo. Okay? Ayan. Sige, maglagay tayo ng ganyan. So if you have questions, guys, just leave a message in the chat box and I will answer them once I see them. Okay, so let's proceed. So for this one, okay, you will need your SPSS. Okay. So I hope you open your SPSS and you already downloaded the exercises file, which I gave you in your Schoology accounts, because you will be needing them for this topic. Ayun. Okay, so let me know if you are still there. Are you still, guys, following me here? Okay, so that's good to know. How about the rest? Nahihirapan kayo sa signal nyo? Ayun. Okay, so yeah. All right, so let's continue. So for hypothesis testing about two independent groups, okay? So we're going to look into a parametric test for testing hypothesis about two independent groups. Okay. When we talk about independent, okay, pag sinabi nating independent, the occurrence of one variable does not affect the occurrence of the other variable. In that case, we say that, or groups, I mean, okay, does not affect each other. So for example, ano pa bang pwede nating ibigay na sample dito? Let's say we test brand A and brand B. Okay, so brand A and brand B, magkaiba silang brand. So these two are independent groups. Okay, so yun. Okay. All right. So for a parametric test in testing hypothesis about two independent groups, it uses means and standard deviations. Okay. So if you're going to perform this manually, you really need to compute for the means and the standard deviations of the two independent groups, because if you're going to use the formula in manually computing for the value of a parametric test for two independent groups, then you need your means and standard deviations. And then we have here samples should be drawn from two normal populations. Okay, so that's another requirement, that the sample should be drawn from two normal populations. In other words, the distribution of the populations of these two samples, or where you got your sample, should be normally distributed. Or when you graph them, they should at least resemble a bell-shaped curve. The sample size should be large enough so that the distribution of the sample mean is approximately normal. This is what I've been telling you earlier. Okay, if you get a sample size from a sample from a population, the size should be large enough, okay, so that the sample means is approximately normal. Okay. Now, if the sample size is small and markedly non-normal, or there are outliers, the non-parametric alternatives are Wilcoxon tests and Mann-Whitney U test. So these are the tests now that you are going to use if any of the assumptions here or the requirements here are not met. So gagamit tayo ng alternative na non-parametric test, which are Wilcoxon tests and Mann-Whitney U tests. Okay? Sige, pag-aralan natin yung mga yan. Huwag kayong mag-alala. Okay? All right. So, two independent samples T tests. So, this is the first test that we're going to talk about, the two independent sample T test. So, when performing a T test on two independent groups, what we are actually testing is the null hypothesis that the two groups, the two group means are equal. Okay, in other words, that the group means are ano bang tawag dito? That there is no difference. There is no difference in the group means. So if there is no difference, they are equal. Okay, so you may state your null hypothesis as the two group means are equal, or you can say that there is no significant difference in the means of the two groups. So either way, against your alternative hypothesis that the two group means are not equal, or the mean of the group is higher or lower than the mean of the other group. So pag gumamit tayo ng not equal, let's say the mean of the two groups or the means of the two groups are not equal. So pag sinabi natin are not equal, it could either be the other one is higher than the other, or the other one is less than the other. Okay. So, yun yung dalawang possibilities. Now, we have two versions of independent samples t-test. Okay, we have equal population variances assumed, and we have the unequal population variances or equal variances not assumed. Okay, in your SPSS later, if you will perform t-tests, it will return values for equal variances assumed and equal variances not assumed. Now, the question is, which value are you going to use, okay, to reject your null hypothesis or not? Okay, so equal variances assumed is used if the Levin's test is non-significant. Okay, the Levin's test is also returned when you perform the t-test. You just have to tick a box in the options section later on for you to be able to compute or to make use of your Levin's test. Okay, so again, we use the equal variances assumed if the Levin's test is non-significant. Okay, when does the Levin's test become non-significant? If the associated p-value of the F statistics of the Levin's test is greater than 0.5. Okay, so pag greater than 0.5 yung p-value ng Levin's test natin, then we say that we use the equal variances assumed. Otherwise, if it's less than or equal to 0.05, then we make use the data for the equal variances not assumed. Okay? So for most of the basic statistical tests that we are going to use, this will be our decision rule. I hope you will take note of this. Ito yung decision rule na gagamitin natin. We reject the null hypothesis if p-value associated with the computed t-value is less than 0.05. Okay? Now, we do not reject HO if the p-value associated with the computed t-value is equal to or greater than 0.05. Please, again, take note of this decision rule. We will be using this in most of the tests that we are going to perform. Again, if the p-value associated with the computed t-value is less than 0.05, we reject the null hypothesis. However, if the p-value associated with the computed t-values is equal to or greater than 0.05, then we do not reject the null hypothesis. Okay? Okay, so example. Now, I'd like you guys to open your SPSS now. Paki-open yung inyong SPSS software. And we're going to use the data exercise.sav. Okay? Remember, I told you to to download this from your Schoology account. So, I hope you have them with you in your computers. At ito yung gagamitin natin. Okay? Exercise.sav file. Alright, so let's take a look at this example. A study was conducted to test diastolic blood pressure reading between patients with sedentary lifestyles, let's label that group A, and to those who exercise 1 hour at least 2 times per week, that would be group B. So we assume, okay, isinulat dito sa problem, that we assume that a parametric method is employed. In other words, i-assume natin without graphing, okay, just for the sake of this example, that all the requirements for a parametric test are met. Okay? Kaya gagamit tayo ng parametric method. So, itong study na tinitignan natin dito, i-compare natin yung dalawang independent groups. Independent. Yung group A, ito yung mga sedentary ang lifestyle. Ibig sabihin, hindi sila masyadong gumagalaw. Walang masyadong activity. Kaya tinawag natin na sedentary lifestyles. Okay? Ito yung mga nakaupo maghapon. Ganon. Walang masyadong exercise. Okay? And then, we have the other group na nag-exercise sila at least 1 hour. for at least 2 times per week. Okay, so meron silang activity na ginagawa. Now, we are going to compare these two independent groups. Bakit independent ito? Kasi yung diastolic blood pressure naman ng group A does not affect the diastolic blood pressure of group B. Okay, so totally their diastolic pressure reading, blood pressure reading are independent. Okay, so walang effect yung blood pressure nung isang respondent dun sa diastolic blood pressure reading nung isang respondent. That's why these two groups are said to be independent. Okay, so since we are comparing two groups, we are looking into the differences of their diastolic blood pressure readings. They are independent. Then we know that the appropriate tests that we are going to use here is independent samples T test. There are two groups. These two groups are independent. We would like to find out the differences in their diastolic blood pressure readings. So therefore, we will use independent samples T test. Okay? So how do we do that? Okay. Let me know, guys, if you have opened your SPSS software already. Pwede ko bang malaman kung nai-open na po ninyo yung inyong SPSS software? Pwede kayong mag-send ng message dito. And I just want to know if you guys were able to open your SPSS software now. Okay. Nagre-restart pa lang daw ng laptop si Eunice. Okay. Sige. Kailangan kasi natin yon, ano? Okay, so while waiting for you guys to open your laptop, so pag in-open nyo na yung software ninyo, mamaya ituro kung paano nyo ilo-load yung file. Okay? Meron na ba kayo ng file na exercise.sav? Were you able to download that from your Schoology? Yung exercise.sav, this one, the one you're seeing on your screen. Meron na. Okay, sige. So, kailangan nyo kasi yon, ano? Dapat meron itong exercise.sav na file. Naka-store dapat siya sa inyong laptop or computers. Okay. So, before we proceed to your SPSS, guys, knowing that this is the situation given, can you type here kung ano yung ating null hypothesis for this type of problem? Based from what we have discussed kanina? Can you type kung ano yung dito? Ano? Kung ano yung ating null hypothesis for this problem? What do you think is our null hypothesis? Okay, anyone? What do you guys think that is the null hypothesis for this problem? Yan. To-check ko kung naintindihan nyo yung sinasabi ko kanina na null hypothesis. No, I'm asking, will you state the null hypothesis? I'm not asking if which one, kindly state the null hypothesis. I-type nyo dito. Sabi ko kanina, sige. Balikan natin yung ating hypothesis. Ayan o. Okay? This is how we differentiate null from alternative hypothesis. I think I gave an example kanina. So can you now state, anyone? Kasi, like what I said, we cannot perform a test without a problem and a hypothesis. Okay, so are we? Okay, so we have here an answer from Harvey. Sabi niya, there is no significant relationship between the two variables. Try to look into the problem. Are we looking for relationship? Yeah. Okay, so Lorraine, sabi niya dito, there is no significant difference between group A and group B. But this is correct, but you have to be specific, Lorraine, that we are looking at the difference in the diastolic blood pressure readings. So a much better hypothesis here is that there is no significant difference in, not between, difference in the diastolic, what do you call this, blood pressure readings of the two groups. Or we can say that the diastolic blood pressure readings of group A and group B are equal. That's another way of stating your null hypothesis. Okay, so be careful in stating your null hypothesis. Kasi if the null hypothesis is erroneous, then parang mali din yung tinitest mo. Okay? Because that's the hypothesis that we are trying to test. So it's very important. The funny thing most of the time is that most researchers, yung mga beginning researchers, nagte-testing na sila but they still do not have their hypothesis. Okay? Which is really funny. Kasi dapat meron kang hypothesis muna. Okay? Mag-hypothesize there's a problem, then you hypothesize on that problem, and then you test to be able to prove, okay, kung tama ba yung ating null hypothesis o hindi. Okay? Or yung ating unang assumptions. Okay? Mga naunang assumptions. So, yun ang kailangan natin gawin. So, dapat alam nyo kung paano mag-state ng null hypothesis, okay, bago kayo mag-test. Okay? So, inuulit ko, when we're looking for differences, effect, relationship, or let's say there's an increase or a decrease, higher or lower, okay, or the effect, is there an effect of the, let's say, a certain drug, okay, in curing a certain disease, ang gagamitin natin dito ay hypothesis testing. So kung meron kayong problem sa research ninyo na ganyan yung problem ng pagka-state, then meron dapat corresponding na null hypothesis. Like what I said, the ratio is 1:1. Okay? So kung yung may problem ka that calls for differences or relationship or effect, then dapat meron kang null hypothesis for that problem. Okay? So if you have 8 problems na ganon, na titignan mo yung differences at saka relationship or effect, then dapat meron ka ring 8 na null hypothesis. Okay? Corresponding to each of the research problem. Okay? So, ganon. Alright? So, I hope clear kung paano ang mag-state ng null hypothesis in this given problem. So, what we're going to do is to open our SPSS. Okay? So, tingnan natin. Paano natin i-open yung ating SPSS? Ayun. Please wait. Di ko mahanap yung aking SPSS. Okay, so I can figure this out. Let me try again. Wait lang, guys. Ayun. Okay, so I hope you guys are here. Nandito na tayo sa ating SPSS. So since we are using, just send me a chat here kapag hindi nyo na-follow. So first thing that we're going to do is we're going to load the file. Yung file natin ay yung exercise.sav. Okay, so ako naka-ready na dito. Hanapin yung folder kung nasaan siya or nasaan yung file ninyo. So this is the file that we are going to use. Ito, exercise.sav. Pag nakita nyo at na-load ninyo, sabihan nyo ako dito sa chat, na-load nyo na okay na. Okay. Alright, so how are you going to load that? Punta lang kayo dito sa open icon, dito sa folder na to. Pag wala kayong ganyan, go to file and then open. Okay, open. No, it's not open. Saan ba yun? Okay, so you can go for data and look for the data. But the most convenient way is this folder here. And then you choose the file. So in this example, we will have exercise.sav. And then you click open. Ito yung open. Just click open. And then revert to saved. Okay, or you can open that in a new window. May lumabas na ganyan sa akin kasi maraming file dito. Okay. So you should have this one on your screen. So we have first column here, respondent number. Okay, actually you don't need to place this one kasi meron naman na dito. But for this example, nakalagay respondent number. Then we have the group. Okay, and then we have your diastolic reading, which group. Okay, so the group here is coded 1 and 2, group 1 and group 2. Okay, so actually, meron tayong coded na ano dito, kung ano yung 1. Okay, nakikita nyo ba ito guys sa screen nyo? Itong anong bang value labels. Okay, here, this one, yung may 1 and A. If you have that in your SPSS, you can just click that one so you can toggle between the use of the code and the label. Okay, ito, pindutin nyo lang siya. So pag tinignan nyo, pinindot ko siya. Instead na yung 1, nagiging group A, sedentary, group A, sedentary, group A, sedentary, group A, sedentary, and so on. Then group B, exercise, group D, exercise. Okay, so you can toggle this between the label and the code. Okay, but since in SPSS, dapat numeric yung gagamitin natin dito, so nag-assign tayo ng code. Instead of writing group A, group A, group A, mag-assign tayo dapat ng numeric na value. Okay, so in this case, ang pinili natin ay 1 and 2. So for example, for male and female, you cannot write here male, female, male, male, female, 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 and so on. Kasi hindi siya ikakalculate ni SPSS. So, ang ikakalculate niya is numeric. So, mag-assign tayo ng value. So, you can assign 1 for male, 2 for female. Okay? So, ganun yung ginagawa natin. Alright? Okay. So, can you guys follow? Let me know if you can follow. Okay, if you can still follow at this point. Now, tignan nyo sa baba ng SPSS nyo dito. Ito. Tignan nyo yung cursor ko, yung nasa baba. We have data view, that's the one we're viewing now. And we also have your variable view. Ayun. Dito sa variable view, dito nyo makikita nyo yung list ng mga variables natin. Of course, yung respondent number is not a variable, nilagay lang dyan. But this may not be included, ano? Then we have the variables here, the group, and we also have the diastolic blood pressure reading. Okay, so yan yun. Okay. I'm not going to teach you muna on how are you going to put a label on the values. Later na siguro. For the meantime, tignan na lang muna natin kung paano tayo mag-calculate. Ano? So, dito natin. So, halimbawa, magdagdag tayo ng another column na variable. Dito nyo itatype sa variable view. Okay? Group, diastolic reading. Halimbawa, sex. Ilagay nyo dito. Okay? Sex. So, you can type sex here. And when you type sex, lalabas siya sa data view dito sa column na ito. Okay, let's try. Just in case we are going to add another one. So you just type sex and then enter. Then your C values here. It will give you numeric and blah, blah, blah. Okay. So you go to data view. Now you have a column for sex. Okay. Then you can start typing. So halimbawa, male. You know, 1 is for male. O kaya, sige, type natin male. Kasi numeric, ano? So 1 is for male, 1. Then 2, female, 1, 2, and so on. Okay? So I'm just showing you on how you're going to enter additional data in your SPSS through the variable view. In our example, we entered sex, but we don't need that one because we don't have a data. So I'm going to clear that. Okay? So this is how you enter data in SPSS. Okay? Para pag kayo later on ay mangolekta ng data, ganito ang gawin nyo. So, by column siya. Ano? So, ganyan. Hindi yung minsan bibigyan ako ng data, male. Inano niya na. Anong tawag dito? Sinamarize na niya. 25, female, 75. Ganon. So, hindi pwedeng ganon. Ano? Yung raw data mismo ang itatype natin. The column. So, for example, in your questionnaire, you have 5. Halimbawa, sabihin mo, rate the following from 1 to, from agree to disagree or something like that. Okay? Highly agree to strongly disagree. Ang isusulat nyo dito, kung 5 questions, 5 columns. 1 per question. Okay? So, ganun yung pagtatype natin. Now, going back to our independent samples t-test, so how are we going to perform that? Okay? So, punta tayo dito sa Analyze. So, pag nasa Analyze na kayo, hanapin nyo yung Compare Means. Compare Means. This one. And then go to independent samples t-test because that's the test that we are going to perform. Okay? Ito yon. There. Are you still with me? Nandiyan na ba kayo? Independent samples t-test. So again, analyze, compare means, and then independent samples t-test. Nandiyan pa ba kayo guys? Nakaka-follow pa ba kayo? Then when you're here, just click that one. And then there's a dialog box that will come out. Okay. Test variable. The variable that we are testing is your diastolic pressure, blood pressure reading. Okay, siya yung magiging test variable natin. Grouping variable. So obviously, the grouping variable is the group that is sedentary and the group that has some activities like exercise. Okay. So yun ang ilalagay natin. So how do we do that? Just click here, group, and then click the arrow dito para pumunta siya doon. Okay? So here, makikita nyo may lalabas na question mark and you see define group. Okay? So group 1. So lagyan natin ng 1 kasi yun naman ang label natin in group 2 is 2. Okay? So ganun lang. We have to define the group. Group 1 is 1, group 2 is 2. So continue. Ayan. Since we only have 2 groups here. Okay, now you can check the options. If you would like to check the options, so wala naman siya. We're not going to do bootstrapping. Okay, that's not part of our lecture. But bootstrapping, tinuturo ko ito sa advanced stat. Okay, and then click OK. And there you go. May another window for your output. Okay, it should look like this one. Yan, may lalabas dapat na ganyan. So if you notice, guys, naka-label dito yung test na ginamit natin. So we made use of t-test. Okay? And then we have here the group statistics. Okay? Basically, these are what we call this descriptives. Okay? Automatically being returned by SPSS. So we have here group A, there are 10 samples. Group B, there are 10 samples. By the way, guys, kapag kayo ay namimili ng respondents, halimbawa may male-female kayo ganon, hindi necessarily na pareho yung number ng male, pareho yung number ng female. Halimbawa, you have 500 respondents, then you can have 220 female, you have 280 male. Okay lang yon. Okay? Huwag kayo mag-worry pag ganon. Yung mga iba akala nila dapat equal. No, hindi dapat siya equal. But these two should be, kung titignan mo yung, if you will be considering later on the sex, then you make sure na hindi naman masyadong, like isang lalaki, then 499 na babae, and then titignan mo kung may pagkakaiba ba yung kanilang responses, hindi naman tama yon. So dapat well represented yung both sexes. Okay. All right, so here we also have the standard deviation. Ano itong mean? The mean here is the mean diastolic blood pressure reading ng nasa group A, yung sedentary, yung walang masyadong activity. Group B, yung may activity, it's 78.80. In other words, mas mababa yung diastolic blood pressure reading ng mga nag-exercise kaysa sa mga hindi nag-exercise. Okay? And then, standard deviation, dito 6. Dito naman ay 10. Okay? Anong ibig sabihin ba ng standard deviation? I think pinag-aralan na natin ito. So when we talk about standard deviation, ito yung layo ng mga scores. This is how far the scores from the computed mean. Okay? So if the computed mean, for example, is 88.10, then our standard deviation is 6.0. So, ibig sabihin yan, that majority or on the average, the diastolic blood pressure reading of group A is on the average is 6 standard deviation points from the mean. Okay, so yun lang ibig sabihin nun. Now, what we are interested is this one. Okay, the independent samples t-test results. Okay, so earlier we mentioned about Levin's test. So nandito, automatic na lumalabas yung Levin's test for equality of variances. Kailangan nating malaman kung alin dito ang gagamitin natin na data because there are two sets of data here. Equal variance is assumed. Ito yan. Ito yung mga yun. And then, equal variance is not assumed. Ito naman yun. So, ang problema natin is, alin ang gagamitin natin? Of course, for this example, almost pareho sila kasi. Pero syempre, kailangan malaman natin kung alin dito. So, ano ang basis natin to find out which of these two will be used? Okay? Ang titignan po natin ay ito. Itong Levin's test for equality of variances. This one, sig. So, what does sig means? Sig is your p-value, the probability value. Ito yung magiging basis natin. So, kung maalala nyo kanina, doon sa unang discussion natin on finding Levin's test, di ba? Sana ba yon? Ano ba ang kailangan natin doon? We will use equal variances assumed if the Levin's test is non-significant. That is, if the p-value is greater than 0.05. So, ang p-value ng Levin's test natin ay itong sig. The sig here is the p-value. And we know that the p-value is 0.184. So, 0.184 is greater than 0.05. So, it means na ang gagamitin natin ay equal variances assumed. Ito. Excuse me. So, we'll make use of all the data under equal variances assumed dahil ang p-value associated with the Levin's test is greater than 0.05 and it's 0.184. So, mas malaki ito kaysa sa 0.05. So, ito ang gagamitin natin. In other words, equal variances assumed, ang value ng t for, this is the t-test. Ano? Itong data na ito ay for t-test. So, the t-value that we are going to use is 2.433. The degrees of freedom is 18. The p-value for two-tailed test is 0.026. Ito. Ang p-value na ito ay para sa t-test. Ang p-value na ito ay para sa Levin's test. Ang hinahanap na natin ngayon ay yung p-value ng ating t-test. So in this case, ang ating p-value is 0.026. Okay? At meron tayong decision rule kanina that if the p-value of the t-statistic is greater than 0.05, then we do not reject the null hypothesis. Okay? We do not reject the null hypothesis. But in our case, mas maliit itong nakuha natin, 0.026. 0.026 is less than 0.05. So, ang gagawin natin ay we reject the null hypothesis. So, going back, ano ba yung ating null hypothesis kanina? Sabi natin that there is no significant difference in the diastolic reading, blood pressure reading of groups A and B. So, if we are going to reject that, therefore, ang ating magiging decision is to reject the null hypothesis, and then ang conclusion natin is that there is a significant difference in the diastolic blood pressure reading of groups A and B. Okay? Can you follow? Paano yung group? What do you mean? So si Eliza Hernandez daw, di na daw siya naka-follow. Okay? Well, there will be a replay of this, ano, naman. So, huwag kayong mag-alala. Mapapanood nyo ito sa YouTube pa rin. Okay? Mas matagal nga lang, pero pwede nyo namang skip yung mga ibang parts later. Okay? Edmond is asking a question, paano daw yung group? I do not know what you mean, Edmond. Kung nasaan ka na. Nakarating ba kayo dito sa part na to? Okay. So anyway, I know that you're having a hard time with your internet connection, like I am. So just in case na hindi nyo na-follow itong part na ito, then you can just go back after our live discussion para makita ninyo. Okay? Kasi na-explain ko naman siya ng mabuti. Okay? So, yun. So that's how we perform t-tests for two independent samples. No, Harvey, there is no. The conclusion would be there is no significant difference in the diastolic blood pressure reading of groups A and B because the p-value na na-compute natin is less than 0.05. I think ang na-compute natin is 0.02 something. 0.026 yung p-value na nakuha natin. Okay? Dito, under sa sig two-tailed, it's 0.026 and that's less than 0.05. So it means, according to our decision rule kanina, that we are going to reject the null hypothesis. Okay? That, ibig sabihin, there is a difference. Okay. Anong ibig sabihin ni Edmond? Iba daw yung lumabas? Bakit iba yung lumabas? Okay, anyway, so just like what I said, you can always go back, okay, review or watch this video para masundan nyo yung ginawa ko. And then, yun, madali lang naman. Alright, so I think we have to end this. Ang next topic natin dito is the non-parametric counterpart of your t-test. Di ba sabi natin kanina, pag hindi na-meet yung requirement ng parametric test, there is always a non-parametric test counterpart na pwede nating gamitin. So for example, may data tayo na pang independent samples t-test, pero hindi niya na-meet yung requirement, okay, or yung mga assumptions, then we will opt for another test, which is a non-parametric test. To give you an example, we will use the Wilcoxon test. But I think we've been online for more than an hour. Yeah, we reject the null hypothesis, Harvey. Kapag less than 0.05, that's why we are rejecting the null hypothesis because what we computed is 0.026. So we reject the null hypothesis. Ano ba yung null hypothesis natin? There is no significant difference. So if you reject that there is no significant difference, then our conclusion is there is a significant difference. Okay. I think you're confused, or is it clear already? Harvey and Edmond? So if you reject that there is no significant difference, it means that there is a difference. Kasi ni-reject mo siya. Okay. Klaro na ba? Okay na? Nagets mo na, Harvey? Okay, so I hope you guys will review this video, lalong-lalo na yung mga nawala. Ano, yung nalito, according to them, nalito sila. I do not know kung nalito talaga or baka hindi sila talaga nakikinig. Ayun, but anyway, you have to review this because I will let you compute later on during your examinations. Okay, so I will give you time to do things, then bibigyan ko kayo ng problem, compute using your SPSS, and you submit it to me. Okay? So, ganun yung gagawin natin na exam natin dito. Alright? So, I think you guys are not responding anymore. So, I don't know what's happening. But, yeah, you can just review. Okay, okay. Yeah, binalikan ko nga. Akala ko may no na nakalagay. Yes, yes. Okay, so I got that, Harvey. Okay, so since there are no more questions, so I strongly advise those of you who were not able to follow in the computation, please review. No, Aiza. Yung Levin's test, yung Levin's test kasi, Aiza, ay para sa pang-test mo kung ano ang gagamitin mo. Kung yung equal variances assumed ba or kung equal variances not assumed. Kasi meron tayong two sets of data for the t-test. Yan nga, yung equal variances assumed, equal variances not assumed. Okay? So, yun. So, gagamitin mo yung Levin's test to decide. Now, pag nakapag-decide ka na kung aling dataset ang gagamitin mo, gamit yung Levin's test, dun ka napupunta sa t-test. Okay? Then, titignan mo ulit yung p-value doon sa t-test. And then, the p-value for that t-test will be your basis in rejecting or failing to reject the null hypothesis. Or simply say, rejecting the null hypothesis or not. Okay? So, yun. Yes, Flory. Nasagot ko na yan kanina. Okay? I thought nilagay niya no. Okay? So, I hope, basta ganun yun. Nasa lecture natin yan, Aiza, no? Kung anong gamit ng Levin's test. Levin's test will let you decide what set of data from the t-test are you going to use. Kasi ang ilalabas ng SPSS ay dalawa. Equal variances assumed and equal variances not assumed. Ang magtuturo sa iyo niyan kung alin ang gagamitin mo ay yung p-value ng Levin's test. So pag nasagot na ng Levin's test kung alin ang gagamitin mo, dun ka napupunta sa t-test na gagamitin mo base sa Levin's test result. And then yung p-value sa t-test, yun ang magiging basis mo for your conclusion. Okay? All right. I think this is already a very long discussion. I know that we have 3 hours allotted, but we are not allowed to discuss for 3 hours online. So we have to stop here, and then I'm going to schedule another one and discuss the non-parametric counterpart of the independent samples t-tests. So if you still have other questions, guys, you can just use our group chat, and then I will answer your queries regarding the lesson. Okay, so that's it for today. Thank you for joining me. I hope you guys have a blessed Sunday, and I'll see you again next time.